Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I'm going to answer to a question that appeared on a YouTube channel to one of the articles that I published a few months ago. The article was about how to use a slicer to select a single date and then build a chart that shows data for the last 6 months before that given date, slicing by month. Among the many questions, there was this one that I found interesting because as it always happens with questions, the question is not completely precise, so I cannot easily author a measure based on the question. But still, in answering the question, I will probably be forced to solve a more generic problem. So it's going to be interesting because we need to work with DAX code and we will probably need to understand a bit also about performance and how DAX solves our query. But as usual, as it always happens with Unplugged videos, I'm totally not sure about what is going to happen. With all that said, I don't want to go on with the introduction with just you looking at my face. So let's jump straight to the article. We refresh our mind about the topic and then we start writing DAX code together. Let's get started. Here is the article. It's an article of a few months ago, how to show the previous 6 months of data from a single slicer selection. And the idea is the following. I want to create a slicer like the one you see here that selects July 2007, only one date. And I want a chart that shows the sales in the last 6 months before that given date. And I created that using a calculation group so that I can use the same technique to show both the sales amount and the margin percentage, which is the line in the same chart. Now, the article contains the entire description of how to solve it, and I'm not going to repeat it here. Instead, on the YouTube channel, among the comments, there is this one from Sabrina. Let me increase the font a bit less. Okay. A bit more. No way. Okay, let's go for this side. Thanks for a great video, Alberto. Thanks to you. I was wondering if this could be used to only show data for every 6 months before a date for a past X amount of years. Now, to be honest, Sabrina, at this point I was completely lost. I had no idea what you wanted to compute. But then she gives an example. For example, company A most recent date is the 1st of June 21. And looking to see sales starting from January up to the end of June. But then so 6 months before the last sale of that given customer that happened to be June. But company B most recent date is the 1st of March. So 6 months before the 1st of March, we'll go back in 2020, in September 2020 to start computing values. If not possible to use this type of example, do you have a similar video? Well, the quick answer is no, I don't have a similar video, but in a few minutes I will have a similar video. Now, the reason why I'm not going to answer the specific question is because this question is completely ignoring the selection on the date, which happens to be the main topic of the article. Let me explain this a bit better with the report. Now, this is the report that you can find in the article. You see, we select July, and we show data starting from July up to February, so 6 months before July. Now, what Sabrina wants to compute is to use a different date for every customer. But the dates, so the last date of sales of a given customer might be in July, or might be in April, in March, in February. It might be everywhere, maybe in January, outside of the previous 6 months. So it's kind of complex to understand exactly what she wants to consider as the last date with sales for a given customer. But what we can do is solve a more generic problem. Instead of solving the problem of computing the last 6 months of sales for the last date of a customer, we go for a generic solution that computes 6 months of sales for any combination of customer and date. So it will be a matter of computing the right combination of dates in order to make it compute whatever she wants. And because we are going to build it step by step, it should be easy at that point to change the part of the measure that are needed in order to compute the value. So let me show you better what I want to compute. What I will do is create a calculation that searches for the last date with sales of a customer in the currently selected month, that is July 2007. So I have a bunch of customers that bought in July. Each has a last date of sales. I will use for each customer its own last date of sales and then move it back 6 months, showing the sales in the last 6 months. This will have two important effects on the report. The first one is that I will no longer see only 6 months. I might see 6 or 7 months, because if the last date of sales of a customer happens to be at the beginning of the month, then 6 months back will go over 6 months from the end of July. So I will probably see 7 months instead of only 6. And the second really important consequence will be on numbers, because the chart right now is showing the sales of any customer in February, March, April. If I link the customer with the data, so if my measure takes into account both the customer and the data, what I will do is define the set of customers that bought in July. For those customers, I will find the last data, but then I will use both the customer and the date as a filter for the past. Therefore, sales of customers that bought in June but not in July will not appear. And as a consequence, my report will have a very high bar in July 2007, and the previous ones, they will be much smaller, because I define the number of customers based on the current selection. Again, you can get rid of this effect by using all in the right point, or by changing the way the calculation will happen. So, with no further ado, let's start writing code. As I said, this is based on a calculation group. So I need to first retrieve the code of this calculation group. So let me open Tabular Editor, so we grab the code of the calculation group, and then we start modifying it. Okay, just go in the right monitor. Here it is. Now, the calculation group is a previous period that contains one calculation item, previous 6 months. And this measure uses a variable to say 6 months, then uses a reference date that is the last date in the current filter context, so the end of July in our example, then takes 6 months back, and the core of the calculation is this calculated that moves the filter in previous dates to the previous date table. As I said, I'm not going to describe how this code works. There is a video that is dedicated to that. I just want to change the way it works. And this is already working. Now, if I want to make it compute a different date for each customer, what I need to do is iterate customer by customer. For each customer, find its own reference date, and then use that as a filter, and finally sum everything together. We can do that immediately using a calculation item. But I'm thinking whether it is better to do the calculation item or to use DAX Studio to write the code. Since I plan to change this code, let me just grab the code. So copy it from here, and instead we all use DAX Studio. Okay. We want to create a calculation that will be a summarized columns. We want the previous date. I'm reproducing now. I need to rebuild this chart, but I need to do that in DAX Studio. previous date, calendar year month, sales amount, and then we use sales amount. Let me get rid of this so we have a bit more space. Why don't you work? Because it's missing evaluate. Okay, this is not yet computing anything. I need to simulate the slicer. So I need to add the filter 3000 July 2007 as date, calendar, year, month. And that is repeating the value everywhere. But then I can use my code. Let me define a measure, sales, how do we call it? Sales amount, 6 month active. So only the 6 months in which the customer has been active. This is the same code as the calculation group. We use sales amount here. And then we use sales amount 6 month active. Doesn't work because it's 6 month active. Okay, this is what it is computing. Let me just check that this number makes sense, and we also need to sort them. So we also need the calendar year month number, and we add an order by at the end. So February is 89 and 922542 is July 2007. Let me check that the numbers are correct. Let me get rid of the margin percentage, transform that into a matrix. Increase the font a bit. Let's go for 20 points. 922542. 922542. Okay, so this is now replicating the same calculation. Now I can start to change it. As I said, this code is working, and it's working fine. But it's not using a different date for every customer. If I want to use a different date for every customer, a simple way is to use a SUMX around everything. So do a SUMX over a customer. And that should already work, except the fact that I'm missing calculate. I need calculate to perform context transition. And I don't need it here. I definitely need it here. So that this is the last date of the given customer. Dates in period does not need calculate. And here we already have it. So this version of the code is already working fine. It iterates customer by customer. For each customer, it computes the last date of that given customer. Then retrieve the previous dates of that given customer, and then this calculator applies the filter on the customer plus the filter on previous dates on the previous date table, so that it computes the sales of that customer in the previous period. Let's just take a quick look at the numbers here. You see that all the numbers right now are quite large. If I now run the code, I expect the value for July to still be very large, but all the previous value, they should be much smaller because now I'm using a filter on the customer too. So if I run it, it does not change in any way. Why that? Six-month active, that is the measure. Okay, there's something wrong here. Oh yes, this is not calculate max of date. This needs to be calculate max of sales order date. Otherwise, that would always be the end of July. So let's try that again. Now I like it much more. First of all, you see that I start to see January. January was not here before. It was starting from February, but because now 6 months are before the last date of the given customer, if the last date is at the beginning of the month, January will start to play a role. And the value for July is still the same. All the previous values are much smaller because there is a filter which is coming from the customer. Now, this version of the code is nice. It's very simple, but unfortunately, it's not optimal. It's not the best code that we could write because we have an iteration over the entire customer table, and this is kind of bad. Let's check quickly at the performance of this measure. The database I'm using is very small, so I do not expect it to be slow. But by looking at the server timings, we can have a preview of the complexity of the code. Let's use bottom layout. So it's only 73 milliseconds. It's very fast. But we have the first query that only retrieves the dates. And this is what I was expecting that I don't like. Look, I select the customer row number, customer key, customer code, customer title. There are all the columns of customers. So this query is retrieving 18,000 customers, all the columns of customer, which is kind of bad. Then it's retrieving customer key and the max of sales order data that is needed to compute this maximum sales order date by customer. And finally, we have the last query, that is the one that likely produces the result because computes quantity times net price. And it's selecting customer key, customer code, customer title, customer name, all the columns of customer, the sum of sales amount with a bunch of joins. And then we have this filter. What I don't like here is that we are retrieving all the columns of the customer table, which is really a lot of columns. So as a best practice, we never iterate over customer. We iterate over the smaller number of columns that is needed in order to compute the value. So we could use here values of customer key, but we can also do one step further because we will compute the maximum sales order date. So we are actually interested only in customers that in the current month have sales. So instead of using values of customer key, I can use values of sales customer key. That restricts the number of customers to only the customers that have sales in the current period. That should have no effect on the result. We can quickly run it to check it. You see, numbers are the same. But if we look at the server timings, I expect it to be a bit better. We still have the first query, then we have the second. The first query is different. That retrieves only sales customer key, where in July 2007. And it's 11,000 instead of 18,000. Then we retrieve previous dates, and then we have the query that only retrieves sales customer key, max sales order data, and finally the last query that retrieves customer key and the columns that are needed. You see that the set of columns is much smaller. This reflects in a small reduction in the execution time, but I'm not worried about the execution time. Right now, I'm more interested in the complexity of the query plan, and then it computes the value. Let me see, because that is quite interesting. Let me explain you what I'm thinking about. Now, when I was writing this code, I was thinking about how to structure the video. And I thought that this SumX was really bad because it introduces an iteration over sales customer key, so 11,000, an iteration over 11,000 rows. And then for 11,000 times I need to perform context transition, compute the sales amount, apply a filter, and do all the other operations. But actually, the engine has been smarter than me, than what I did. The optimizer really did a splendid job here. Look at how it executes the query. As I said, first it retrieves the customer keys in July 2007. Then it retrieves the dates. Then for each customer, it retrieves the maximum sales order date. This generates a table that contains the customer key and the date. Then the magic happens here in the last query. Because we have the select part, but look at the where condition. The where condition has where customer key in, and here we have the list of all the customers that happens to be in July 2007. And then we have sales customer key, a new filter that is working on sales customer key and previous date. So it's filtering two columns, the customer key and the date. So this customer, this date, this customer, this date, this customer, this date, and so on. And it generates quite a large filter, 150,000 rows. So it's a large filter that is applied to the model, and it executes the entire calculation with a single scan, which is very good because it's an optimal execution path. It only scans the table once with quite a large filter. So I was thinking about how to optimize this code using this technique, but actually the optimizer has been better than myself because he did the job instead of forcing me to do the calculation. So this code is already very good and it works, but it has a major drawback. And the biggest problem of this code is that it does not work if the measure is non-additive. It works with sales amount because sales amount is an additive calculation that computes its value by adding partial values. But if you were to use it with a distinct count, for example, that calculation would fail because it is using a sum x. So customer by customer, this part of the code would work in case of a distinct count, but then the partial results are summed together. And summing distinct count simply doesn't work. You cannot sum distinct count. Distinct count is non-additive by its nature. So if we want to implement this as a calculation item, we need to do a step further. We need to make it work in any scenario, whether the measure is additive or not. And to make it work, we will basically do the same thing that DAX is doing, but we will need to do it earlier. Let me explain, or at least try to explain this. What we will do is create a table that contains a table that contains the customer and the reference data. Then we will expand this table to a new table that contains the customer and all the dates in which I want to compute. So first I start with a customer and the last date of sales. Then I expand this table by adding all the dates that happen to be before the last date of sales of the given customer. And I generate a table with two columns, customer, date. Same thing that the optimizer was doing with my code, but I will do that in DAX. So in order to control the application of the filter. Once I have the table, I will apply the filter, and that will work regardless of the measure I'm using being additive or not. Let's do that. And again, we need to do that one step at a time. So let me save all these. I create a new window where I still have the same calculation, but then I want to create a new, let's call 6-month active non-additive. And then we use an A here. Same result, but then we need to start changing it. So first we need to create a table containing the customer and the maximum sales. So we start with a variable that we call customers and last date, where we use add columns to the values of sales customer key. We add a new column that we call last, let's call it reference date. That is this code. Okay, this table contains the customer key and the last date with sales. Then we need to expand this table. I want to generate a new table that contains the customer and all the dates that happen to be 6 months before the reference date. This variable number of months is still good. Let's call it customers and dates, and we use generate. For each row in customers and last date, we generate the dates in period. In previous date, now we no longer use the variable because we no longer have the variable, but we have in the row context the reference date that I'm computing here. Okay. And once I have this, once I have my table created with generate, I can use calculate, sales amount, remove filter of date. Keep filters will not do a keep filter on previous date, but on customers and dates. And then return result. You see that in this version of the code, I no longer have SUMX. I got rid of SUMX, so I'm not forcing additivity. I'm using whatever kind of additivity is defined in sales amount, because the entire code is first compute the filter and only then apply the filter. If I run it now, I do not expect it to compute anything different. These are the values here, and these are the result, and they look identical. They are, but the logic of the code is very different. Let me just check quickly that this is not terribly slower than the previous one, but I do not expect it to be slower because I just made it explicit what the engine was already doing. It's 55 milliseconds against 41. It's around the same time, maybe a bit slower, but not significantly. And it has the advantage that this is going to work in any scenario, regardless of the measure being additive or not. Not only this, but you see that by splitting the calculation, I have a first step where I define for each customer the reference date. Then I have a second step where for each customer I define the set of dates that I need to use based on the reference date. And finally, here I do the calculation. So that is useful because whatever logic you want to implement in the measure, you can change a part of the code and make it compute whatever you need. Now that I have written the measure this way, I can actually copy everything and create my calculation item. So I can go back to tabular editor. Okay, we can create a new calculation item. Let's call it previous 6 months active. I put my code. Let's format it. And I do not need to use sales amount here. Now that I'm in a calculation item, I can use selected measure. Okay, save it, go back to Power BI Desktop. I need to refresh. Now you see that these are the values if I use for previous period, the previous 6 months, but if I use the previous 6 month active, then I have a different value. And this is going to work with the margin percentage, with distinct count, with whatever calculation you place, because it is no longer based on the forced additivity that was introduced by SumX. So let's draw the conclusion as usual. As you have seen, I started from a question. The question was quite specific, how to use the last date of sales customer by customer. And instead of solving that specific question, I went for a different trip and a different kind of calculation. Still a calculation item and a measure, because we implemented first as a measure and then turned it into a calculation item that solves a more generic problem. It is interesting because it shows how to think in terms of DAX. It shows that iterators are not always bad. In this very specific scenario, the presence of an iterator has been actually removed by the optimizer. That has done really giant leaps forward in making it better, in optimizing code, even if it is not perfectly optimized. With that said, in order to make it work in any scenario, so for additive and non-additive calculation, we still had to be explicit and write in DAX first the filtering part and then only at the end the entire calculation. I hope you enjoyed the video and as usual, enjoy DAX!